Hello, we are going to look at the solutions for the exam taken on the 27th of May 2021 for the module Electrical Principles. The first question, as usual, is to convert some unit of measurements. A, 1200 kilovolt to how much volt? So we say 1200 and kilo will be replaced by 10 to the power 3. You can either leave it like this, or you can convert it to this one, just change it to 1.2 and increase the power of this 10. B, 0.15 milliamp, how many microamp? So we put 0.15 and we replace milli with 10 to the power negative 3. Then we say, okay, this is amp, but we want microamp. So that is 10 to the power negative 6. So I have to deliberately multiply by the inverse of 10 to the power negative 6, which is 10 to the power positive 6. You can put this kind of notation in the exam, or you can quickly put the final value if you're confident enough or experienced. In the end, you get the mark of each section only for the final value. This is only for question number 1, because there is no formula, no, let's say, approach that will be marked for this part. So it's only important to have the final number correct. C, 2500 picofarad. The other way that you can solve this is, okay, you see, this is picofarad and you're going to transit to nanofarad. So you say 2500 pico is replaced by 10 to the power negative 3, and then immediately you can multiply by the inverse of pico, which is 10 to the power positive 9. And then you can simplify this. You see, 2500, I wrote it like 2.5 times 10 to the power 3, and then we had this 10 to the power negative 12 and 10 to the power 9 as the inverse of nano. And looking at this part, you see that will be 1. Because 3 plus 9 is 12, 12 minus 12 is 0, and you know any numbers power 0 is actually 1. So the remaining is 2.5. Similar to this, we have this one in section D, 3.2 times 10 to the power 9 hertz. And the question is how many or how much megahertz? So here you don't have to do any replacement. Basically, you copy what you see here, 3.2 times 10 to the power 9. But we need to multiply by the inverse of mega, which is 10 to the power negative 6, because mega is 10 to the power 6. E, 0.005 microhenry. This is going to be replaced by 10 to the power negative 6. And then the question is how much picohenry? So pico is 10 to the power negative 12. You need to deliberately multiply by the inverse, which is 10 to the power 12. And then you simplify. I even change this 0.005 to 5 times 10 to the power negative 3. It's like you're dividing 5 by 1,000. No, this is 0.005. So in this way, you can look at this part, simplify this one. You see that is going to be 10 to the power plus 3. So 10 to the power plus 3 times 5 is 5,000. And the last one, 920 micro O. Micro is 10 to the power negative 6. In the question, we need to make it like milli O. So it's like you multiply this by the inverse of milli, which is 10 to the power 3, or 1,000. Question number 2 says there is a storage whose current state of charge is 40% of its full capacity. The full capacity is 1,000 watt-hour, and a watt-hour is the unit of energy. And they say it takes 45 minutes from now until the battery gets full. And we know here, if we go for hours, because energy is given in watt-hour, and if I want to calculate power in watt, I need the duration of time in hours. So 45 minutes can be written as 0.75 hour, or 3/4 hour. We have this definition of power and energy. We say power equals energy divided by the duration of time. So energy here is the amount of energy you need to transit from this state to full state. So that is 1,000 minus 40%, or in other words, you can say it's like 60% of the capacity of the battery. So 60% of the full capacity of battery, 0.6 times 1,000. This is your energy. This is the energy you need to move from this point A to B. Then you need to divide it by the duration of time in hours, which is 0.75. And you get 800 watts, which is the power of the system. Section B is about energy, but in joule. So energy is power multiplied by time. Power is 1,000 watt hour. If you replace hour by seconds, we will actually convert this unit of measurement of energy to joule. So 1,000 multiplied by 3,600 seconds. This is the total number of seconds in an hour. That's gonna be 3.6 million joule or megajoule. Part C is a different question. It's about calculating the resistance of a cable whose length and diameter is given. You need to pay attention if you have cross-section area or diameter. Eventually, what you need in this formula is cross-section area. In this question, we have diameter of the cable, which is 3.5 millimeter. You can calculate cross-section area of this cable. You can assume that the cross-sectional area is a circle, so pi r square, and you can calculate it. As 3.5 millimeter you're using, so the cross-section area would be 19.2 millimeter square. You're using millimeter, sorry, so that is millimeter square. So when you go to this big formula to calculate resistance for the cross-section area, you need to convert it to meter square. So that 19.2 has to be multiplied by 10 to the power negative 6. Other elements are all what you had in the question. For example, resistivity was given, and L or length was also given, 90. Just double check if it was meter. Sometimes it may be like 1.2 kilometer. You need to convert it to meter. So you get 0.08 O as the resistance of this cable. Question number 3 is to calculate the total resistance of this system. So you have combinations of parallel and series resistors. If you look at this system, you see 3 and 7, they are connected in series. So you can quickly replace these ones by their equivalent resistor. 3 plus 7 is 10. Then you see 10 and this 10, they are parallel. You know, in general, to calculate parallel resistors, you need to multiply them, divide by the sum. But in case they are equal, it's even easier. The equivalent resistor equals half of one of them. So the equivalent resistor for this part is just 5, which is half of 10. Okay, so this is, everything here can be replaced by 5. Let's look at this part. A general formulation to calculate the total resistance of parallel resistors is the inverse of the total resistor equals the sum of the inverse of each single resistor. But the other way is you can select a pair of resistors, replace them by an equivalent one, and then take another one which is parallel to them and do another operation for parallel resistors and so on and so forth. So I take these two 10, 10, they are parallel. The equivalent one is just 5, okay? Then 5, 5, they are parallel as well. And the equivalent one is just half of them, which is 2.5. Again, this is easy to be halved because they're equal. If not, you can multiply them and then divide by the sum. You know, the formulation, the exceptional formulation for two parallel resistors. Anyway, this is replaced with 2.5 ohm. So we can say this network has been reduced to this one, 2.5, 2.5, and this part 5. And if you look at these resistors, they're connected in series. You can simply add them. 2.5 plus 2.5 is 5 ohm, plus 5 is 10. So overall, the equivalent resistance of this system equals 10 ohm. Next question is about total current. Total current equals total voltage divided by the resistance, the total resistance. Pay attention, usually in section B, the voltage is different from what is given in the diagram. You see in the diagram it is 100 volt, but in section B that is 35 volt. So you need to put 35. Be very careful. 35 divided by 10, which is the total resistance, and you get 3.5 amp. We had another part in this question saying what is the current measured by that what was the voltage drop of that 7 ohm resistor, the 7 ohm resistor. This is actually the right side of the original diagram. And if I go to calculate the voltage drop here, I need current here. If I know the current, then simply I can multiply it by the resistance and I can have the voltage. But what's the current going through this branch? We know the total current now, 3.5. We just obtained it. 3.5 arrives in this node, and then it is divided into two branches. This is one branch, this is the other branch. It's like this part is like this, no? You have this 10 ohm, and this is 10 plus 7, which is 10 ohm, another 10 ohm. So 3.5 arrives in this node, and it is divided in two parts. By looking at this specific example, we see that two branches have equal resistances. So obviously the current is halved. Half of this current will flow through this branch and half will flow through this branch. If they were not equal, you would have calculate the each current, or for example this current at least, using current divider rule. But here it's easy, you just divide 3.5 by 2 and you get 1.75 current flowing here. When I say current flowing in this branch, it doesn't matter if it's flowing through the total 10 ohm resistance of this branch or flowing through each of these resistors. Anyway, there is 1.5 amp flowing through this branch. So I can say current experienced by the 7 ohm resistor equals 1.75. And if I multiply it by the value of the resistance, I get the voltage drop, which was the question here. Question number 4 is about AC circuit. There is a capacitor, a resistor, and a reactor and a resistor. The reactor and the resistor together form a coil. The question is, what is the inductive and capacitive reactances? And so inductive reactance equals 2 pi FL. Pay attention here. Sometimes F of frequency is 50 Hertz, sometimes it's 60 Hertz. Here it was 60 Hertz. So you need to replace F by 60. L is given 100 millihenry. Another thing that you need to pay attention is the unit of measurement. This is millihenry. So you need to put times by 10 to the power -3. To calculate the capacitive reactance, you use the same formula, but in an inverse way. Very careful, be very careful. This should be inverse, 1 over 2 pi FC. Again, frequency is 60 Hertz, C or capacitance is 25 microfarad. So that is 25 times 10 to the power -6. It's like, if you have 10 to the power -6 here, you can remove or shift it to the nominator and just change the sign. So it's like you're dividing 10 to the power +6, 1 million, by 2 pi F25. Anyway, this is only the calculation part, and normally calculation has less than 30% or 20% of the mark of each section, but you can use your calculator to work out this one. We go to section B, which is about the impedance. So impedance, this is the general formulation. Impedance equals root square R squared plus the difference of XL and XC. It doesn't matter which one to be deducted from which one, because in the end, whatever value you get here is squared and will be positive. In our case, we had resistance in the question, And we calculated the capacitive reactance and inductive reactance in section A, so we can obtain the impedance. Section C is about the total current, which equals total voltage divided by this total impedance. Total voltage in the question was 120, and total impedance is what you obtained in section B, 70.09. And section D is about the angle between current and voltage, which is actually the angle between total reactance and resistance in the impedance triangle. That equals tangent inverse x over r. Tangent inverse, the difference between x and r, the xl and xt, divided by r. And yeah, this needs to be calculated. I've not done this, but you can use your calculator to see firstly what is this value, and then what angle, what is this value, and what angle has this as its tangent. Here, as capacitive reactance is greater than inductive reactance, the system is leading, current leads the voltage, and this is the phi you obtained here. Question number 5 is about transformers. In section A, we need to calculate the secondary voltage. So in the question, you can find a primary voltage as well as the ratio of the transformer. So that's just a matter of replacing in this formula. V1 over V2 equals, N1 over N2 equals V1 over V2. N1 over N2 is given, which is 1 over 5. V1 is also given, 230. So we can calculate V2. This is actually a step-up transformer. It increases the level of voltage 5 times. So obviously, if the given voltage is 230, the output voltage is 1,150 volt. Section B is about primary current. So if I go for the primary current, I can use this formulation saying N1 over N2 equals I2 over I1. Here I have it. N1 over N2, I2 over I1. If you look at this formulation, you see N1 over N2, which is the ratio of transformer, is given, but neither I2 nor I1 is given. Here the question is about I1. So I need to have I2 in order to calculate I1. Do I have I2? Not so directly, but indirectly, yes, I do have I2. How? So I2 equals power divided by voltage at the secondary side. Both of them are known. Power is given 1.15 million watt, and V2 is 20,000 volt. So based on the definition of power, you can calculate the current on the secondary side of this transformer, and then you can get back to this formula in order to find I1. Okay. Section C. It's only based on the definition of power. Power equals multiplication of voltage and current. Secondary side, no problem. I2 equals P2 over V2. Everything on the secondary side. P2 in this section is 2 megawatts or MVA. 2 million divided by 22,000 volt, and you get 90.9 amp as the current of the secondary side. Question number 6 is a circuit. Here the power of the load is given, and we are asked to calculate the current of the load. So based on definition, power of a load equals Ri squared. This is also power dissipation in a consumer. It's also power loss calculation in a cable. In general, this is another representation of power. Power equals Ri squared. So I equals root square P over R. P was given 100 watts, and R is 4 ohm. So you can work out, you get 5 amp. Section B says, in general, in the question, not even in section B, they say that this load is consuming the power at its maximum. So power is maximum. When power here is maximum, then the resistance of the load equals the resistance of the system. When I say system, sometimes this can be the internal resistance of the battery. This can be the Thevenin resistance of the rest of the network. It doesn't matter. Any series resistance, excluding the load, should equal the load resistance. So R, lowercase r equals uppercase R load. So R equals 4 ohm because load was 4 ohm. Then the question is also, what is the voltage of the source? So voltage of the source in general, equals total resistance multiplied by total current. We do have the total current from section A, which is 5 amp. And now we also have the total resistance, which is 4 plus 4. Okay, so it's like 8 ohm in total multiplied by 5. 8 times 5, which is 40 volt. This is the total voltage. Section C is about the energy in joule. So power times duration. Power was given 100 watt, and duration is said to be 4 hours. So that is 4 times 3,600 seconds, because the question was, what is the energy in joule? So you need to calculate it based on seconds. That's going to be 1,440,000 joule, or 1.45 megajoule. Last section is about the cost of energy. If per kilowatt hour, you need to pay 11 pence. So energy, we obtained it, or we had it in watt hour, because we have the power, which is 100, and we have the duration. So 100 watts multiplied by 4 hours will be watt hour. We need energy in watt hour here, not joule, because